So for a scale, we have the diagram number and the actual number. We can write it as a scale. And we can also make it a scale factor. The scale factor usually is a fraction, d over a, and we can also get that to be a decimal sometimes. So we can take the top number divided by the bottom. We also sometimes called it the new over the original. Writing that down can really help you. So new over original. And we usually use those words mostly for scale factor. Your units must be the same. So it's going to be centimeters to centimeters. If you change them, like we're going to do for the map question over here, then make sure you write down your units. But if I don't give them to you, it's centimeters and centimeters. So we have a drawing of a bike, 8 centimeters. Actual bike is 6. All right. So diagram to actual, 8 centimeters to 60 centimeters. What should we do now? What should we divide by? 8. We want to get one of them to be 1. Okay. What's 60 divided by 8 though? Pulling out the calculatrice. Is that right? I think so, isn't it? 7.5. Did we like that? No, we usually try to get rid of the decimals. Now, if you see that as an answer, that's it. But what could you do to get rid of your decimal? Times it by 2 because your denominator is 1/2. Its denominator is 2. So your scale will be 2 to 15. Okay? We would give you one of those, but not both. Okay? We wouldn't have them both fair because both technically could be correct. All right? Well, they are the same. Any questions? Okay. What is the scale factor? So we take 2 to 15. We turn it into a fraction, 2 over 15. Go to your calculator and turn it into a decimal. 0.13 repeating. Again, we would give you either the fraction or the decimal, but we wouldn't have both as a possible answer because they're both the same value. They're the same. Any questions there? Okay. The next one. So we have a map. You measured on the map 2.5 centimeters. You want to use the scale to figure out what's the actual distance. Does it make sense to measure the distance from Abbotsford to Chilliwack in meters? Not really. Centimeters? Definitely not. What will we usually measure the distance in? Kilometers. Okay, so what you can do is you can convert your scale, then find your measurement. Okay. Or you can find your measurement and then convert your scale. Those are the two things you have to do. It doesn't matter the order. What I'm going to do is convert first. So I'm going to take 600,000 kilometers. Then I'm going to convert first of all to meters. Because say I wasn't given this, okay, if I wasn't given that conversion factor, I know for myself I'd have to convert into, I'm sorry, I'm screwing this up. This is not kilometers, it's centimeters. I'd have to convert to meters first. So how many meters, sorry, how many centimeters are in 1 meter? 100. Okay. Then I'd have to convert my meters into centimeters. Sorry, meters into kilometers. So 1 kilometer has 1,000 meters. I have my units line up, so centimeters will cancel, meters will cancel, and what am I left with? Kilometers. So I can take my calculator, once I've gotten this written down, 600,000 times 1 divided by 100 times 1 divided by 1,000, and it's 6 kilometers. Now, since I'm given the scale factor, I could also take 600,000 centimeters and times it by 1 kilometer and divide by 100,000 centimeters. If you do that on your calculator, you'll find it's also equals 6. So I showed you two methods there. All right, your choice which one to use. So what we can do is take our scale and write it as 1 centimeter represents 6 kilometers. I specifically write down my units so I remember what they are, because they're different now. Okay. Diagram over actual. Write that down too, please. So where should your 2.5 centimeter measurement go? Top or bottom? Top. Why? Yeah, it's from the diagram, right? So it's 2.5 centimeters on the map, which is your diagram. X is on the bottom. Okay. Now, scales are so easy to do math with because you have the number 1. Okay, so what we can do is go 1 times X equals 6 times 2.5. Really what we're doing is getting our fractions to be equivalent. The top was times 2.5, so the bottom must be times 2.5 as well. X equals 15. So was that dogs, pigs, cats, goats, horses, or kilometers? Or centimeters? Kilometers. Good. Okay, 15 kilometers. Okay. And that's because the bottom of the fraction is kilometers. So this is kilometers. X must be in kilometers. You guys okay? You seem very sleepy and tired today. Yeah? Late night last night? Too much fun on a Monday? Okay. Okay, so determine if the shapes are similar. You must support yourself with a decision. Sorry, support your decision with a reason. So your reasons are, what are the two reasons? Angles are the same. If you have a triangle and you have angles that are the same, then you have similar figures. Or sides in equal ratios. And make sure you line up big with big, medium with medium, small with small, so you figure out the ratios properly. Okay? So this would be big and big, medium and medium, small and small. Okay, go ahead, do A and B right now. Go. Tell me if A is similar and then give me a reason. So one rule of triangles is they add up to 180 degrees. So 180 minus 110 minus 30, what does that equal? Is it 40 degrees? If you don't know the angle, you got to find it. The other one will be 180 minus 40 minus 30 equals 110 degrees. Find all the angles first. So now, are these triangles similar? Yeah, they're similar because angles are the same. Okay, good. What about the next two? So I'm going to line up 2.5, the smallest side, with the smallest side of 7. I'm going to line up 3, the middle side, with 7, the middle side. I'm going to line up 4 with the large side. Okay, that equals 0.3 repeating. 2.5 divided by 7 equals 0.35. Sorry? Oh, sorry. This should be 9. I was worrying about that. Thanks. 0.3 repeating. There we go. That's what I was looking for. So, are these triangles similar? What? 4 is the largest side, so it must match up with the largest side. But what? Just you think they overlap perfectly? Why don't you flip it, rotate it, spin it, right? You can't. It's impossible to have sides of different lengths matching up that way. Okay, so you have to do large with large, small with small. Right? So the reason is no, they're not similar because the sides are not in same ratio. Okay. Any questions, Sarah? What angles are given to you in that question? Yeah. So if you had something like A and they weren't the same, then yes. But if I don't give you the angles, we got to say something about the ratios. Okay. Now we have a different shape. What kind of shape do we have for C? Rectangles. So now you have to have both angles and sides. Okay, so we're talking about sides and corresponding ratios. So let's take our small side 6 divided by 2.4. It could be the other way around, that's fine. Our large side of 15, divide that by 6 and see what we get. So 6 divided by 2.4 equals 2.5. 15 divided by 6 equals 2.5. So are these shapes similar? Yes. And that's because we have equal, whoops, good job, Mr. Worker, equal angles and sides in the same ratio. Good. All right, so for any other shape, you must have 2 reasons to be true. Okay, any questions? D, solve the proportion. Notice how these 2 fractions are both equal to 3 over 4. So that's what we need to do, is we need to set 3 over 4 equals 17 over y, and 3 over 4 also equals x over 8. X over 8. This is an x. I know, you're doing the math already. Just slow down for a bit, right? What if it, okay? Good. So get it y out of the basement. 3 times y equals 4 times 17. So 3y equals 68. 22.7 repeating. Sorry, 22.6 repeating. So we'll round it 22.7. Okay. Now Tony, super smart. She saw, well, if it's 3 over 4, it must be 6 over 8. Now if you don't get one that's easy, instead of dividing by 8, you times it by 8. And so you get 24 divided by 4 equals x. x equals 6. Okay? So we had some very easy equivalent fractions there. Most likely they'll probably give you some decimals and stuff, so it won't be so easy. Yes, sir?
Can you 3 divided by 4 and get times 5 and times 17 by that, or does it not?
Times, not for this one, no. Because y is in the basement, that's not going to work. You've got to get y out of the basement first. Okay? But for this one over here, because x is on top, that would work. Because the opposite of dividing by 8 is, and that's why. Okay? All right. Any questions? Good. Next. So you have to write proportions, then solve. So which triangle do you want on the top? The left or the right? Someone yell out. Left. So write that down so you're not confusing yourself. You remember what you did as you're doing the rest of your work. Okay. So 3 fractions. The left triangle is x, 15, and 8, and the order is fine. What side matches up with x? 12. Good. What other marking can I put on the diagram? I should put on the diagram. Okay. Those are equal. You should show that they're equal. Okay, those are opposite angles. When 2 lines cross, you have those being equal. Okay. So underneath 15 is between open dot and closed dot. What side is between open dot and closed dot? 10. So 10 must go underneath 15. What goes underneath 8 and why must it go underneath 8? Pardon? Why? Why? Closed dot and nothing? Closed dot and nothing. Good. Your angles help you match up your sides correctly. Okay, so we have 2 pieces of work. We have x over 12 equals 15 over 10. And we have 15 over 10 equals 8 over y. Go ahead, solve for x and y. I'll give you some. So here we have x equals 12 times 15 divided by 10. X equals 18. Over here we have 15 times y equals 10 times 8. So then y equals 80 divided by 15. I did something funny there. 5.3. Any questions? And people got both answers. Hands up. Okay, good. Okay, next one. Which one do you want on top, the big or the small? Doesn't matter. We'll choose big, small on the bottom. So you have 4 fractions. X, 15, 20, and 17. You go ahead, match it up, find your missing side, see what you can do. Okay, so what goes underneath x? 8 underneath 15? No, yeah, we don't know. Okay. Underneath 20? 7.2. And underneath 17? Y. Well, now what you should have done is you should have marked these as being equal. I hope you did that. Okay, it's a really important thing to notice and see. It's going to help you a lot. Yep. Do you know what that is? Then why did you say it's 15? Because you're making it up and it's scaring you that you can leave it blank. It's okay to leave it blank, right? If you don't know, you don't know it. Okay? We actually don't care about that fraction. You have to have only one fraction where you know both numbers. Right? This fraction here, that's gold. You use that for both questions. So one's going to be x over 8 equals 20 over 7.2. The other one will be 20 over 7.2 equals 17 over y. If you haven't solved it yet, I'll give you one more minute. Go, solve it, please. Okay, so x equals 22.2 repeated, y equals 6.12. Any questions? Okay, next one. When you get a shape like this, it's helpful to redraw both triangles. So here's your large triangle, and here's your small triangle. Please write the measures on there appropriately, please. Go. Okay, what's the measurement on the large triangle? You should have 90 degrees, 90 degrees, 18. What's this one? Wrong. It's the whole side. X plus 6. Okay. So let's put, for this, which triangle should you put on top and why? What's going to give you the easiest math? Looking ahead. Why? Yeah, because X is on the top then. Okay, so big over small. Then we get X plus 6 and 18. And we get 6 and 3. Okay. So there's some easy ways and some hard ways. What's one way of solving this? There's actually three good ways of solving this. Diction. Common and multiple denominator, yes, that's the best. So multiply both of these by what? 18 works. Is there a smaller one? 6 works. Okay, so 18 will totally work though. So multiply this by 6. The only thing you have to be careful of here is what did I add in red? Brackets. So that's a little tricky there. Okay. Now, how else you could solve it would be this. What's the opposite of dividing by 6? Timesing. So then you can get x plus 6 equals 6 times 18 divided by 3. Okay, so x plus 6 equals, I'm not sure here, hold on. 6 times 18 divided by 3, 36. So then x equals 30. Okay. Exact same thing on the other side. If I solve it differently, divide and get 1 and 1. Divide and get 2. So x plus 6 equals 36. X equals 30. So two very different ways of doing it, or similar. Okay, you choose whichever method it works. Now, if you always do cross multiplication and say that, you're actually doing a lot more work. But you're welcome to do it that way. I'm just not going to show it because it's not good to say cross multiplication. Good. Okay, any questions? For your homework, you're going to set up a lot of fractions. Make sure you're doing that. Here's 10